Hey everybody, this is Sam Hin with NLCAA. Today we're looking at the 2019 Title 24 lighting control requirements pertaining to Section 110.12c demand responsive controls. So currently we are in the 2019 Title 24 code cycle. Previous code cycle was 2016. When we look at demand responsive control requirements, in the previous code, it was in section 130.1e. New for the new code, it got shifted to its own section under 110.12. The reason being was because before they had lighting controls and they had the HVAC zonal controls when it came to demand responsive controls separately. Putting it in section 110.12 just consolidated the two so that it's all under the same topic, which is your demand management requirements. Before we start jumping into the code requirement and trying to figure out if our project has triggered this requirement, we should really look into the definitions of all the terms that are related to demand response or demand management. And you'll find that under section 100.1 in the code. And so we'll just go through these terms and definitions and just kind of read through them. The last one is the one where I'm more focused on, but let's go through them all. So what is demand response? Code defines it as short-term changes in electricity usage by end-use customers from their normal consumption patterns. Demand response may be in response to, there's 4 of them, changes in the price of electricity, participation in programs or services designed to modify electricity use, could be in response to wholesale market prices, or when system reliability is jeopardized. What is a demand response signal? It's a signal that indicates a price or a request to modify electricity consumption for a limited time period. And last, what is a demand responsive control? Okay. It's an automatic control that is capable of receiving and automatically responding to a demand response signal. Looking into demand responsive controls a little bit further, what demand responsive controls is either of 2 things. It's either a certified OpenADR 2.0 A or B virtual end node in the applicable OpenADR 2.0 specification, or it's certified by the manufacturer being maybe the lighting controls manufacturer or the building automation manufacturer, as being capable of responding to a demand response signal from a certified OpenADR 2.0 virtual end node. I don't know what all this means. Just kidding. Actually, I do know what it means. What you should take away from this is OpenADR, which stands for Open Automated Demand Response. It's a standards-based demand response protocol, and what we know about it is that when we have to do demand response because we have triggered because our building design or our install has triggered this requirement, then we know we have to provide a lighting control system that is capable and also certified to this OpenADR 2.0 A or B standard. When our exceptions testers are going out there and they know they have to check for this demand response requirement, one of the things they must do is check and make sure that it's standardized to this OpenADR protocol. And if it's not on the website, then they're looking for this secondary proof documentation indicating that it is certified. We now know what the standards-based protocol is when it comes to demand responsive controls, but what are the different communication methods to ensure that the lighting control system or building automation system is receiving the signal and responding? You could do one or more of the following methods. It's either through Wi-Fi, Zigbee, BACnet, Ethernet, or hardwiring. I would say most systems today are utilizing Ethernet communication pathway. This last statement, when communications are disabled or unavailable, all demand responsive controls shall continue to perform all other control functions provided by the control. So yeah, there's a lot of control in this this sentence here, but all this really means is when the demand responsive controls has been disabled, or there's a disruption in the communication, your lighting control system shall continue to operate 100%. There's no reason for it not to operate properly. So that's all this means. Okay, so let's dig into the actual mandatory requirement and see if we've actually triggered it. So this applies to this demand response requirement applies to buildings and building scopes of over 10,000 square foot. If we are, then it must be capable of receiving this DR, or demand response signal, and reducing lighting power. During the acceptance testing for demand response, system must be able to demonstrate that there has been a lighting power reduction in the controlled areas by a minimum of 15% below the installed lighting power. Your exceptions would be so you would exclude spaces where you have a lighting power density of less than or equal to 0.5 watts per square foot, which do not count towards your 10,000 square foot threshold. So you may be in a larger space that may occupy 20,000 square foot, but if the majority of your floor space is under 0.5 watts per square foot, there's a pretty good chance you have not triggered this code requirement. And then you have spaces where a health or life safety statute, ordinance, or regulation does not permit the lighting to be reduced, are not required to install demand responsive controls, and do not count towards, again, this 10,000 square foot threshold. Okay, so let's apply what we've learned. And our example here is about a 50,000 square foot warehouse building. And if we look at the floor space and how it's being utilized, what we're indicating here is that, of the 50,000 square foot floor space, 5,000 of that is being utilized for administration and office areas. And we're saying we're over 0.5 watts per square foot in those areas. For the remaining 45,000 square foot where we have, just storage and open areas of the warehouse, we're saying that we're under 0.5 watts per square foot, which is very common. And so we have to determine if we've gone over this 10,000 square foot number threshold. And the answer is no, we did not. And it's because we've excluded 45,000 square foot of this scope. And the number that we ended up with is well under 10,000 square foot. We were only at 5,000 square foot. So this is a perfect example of where some folks, without really reading into code, may assume that their building's over 10,000 square foot. They assume that they have to do demand response and start specifying the product, start installing the equipment, start going through the testing procedures. All unnecessary. As long as we actually read through code, understand the exclusions, and apply it, we could save a lot of time, money, and headaches. That concludes our lesson for today. Thank you very much. Hope to see you again.